All right. As I said, my name is Phil Zito. Thank you for joining the Basics of Building Automation Programming webinar. That's me on my first day as the president of Building Automation Monthly. So we are a provider of online training, also a provider of free podcasts and webinar series like this. We help companies to figure out what their people know and don't know, and then we help train the skill set gap so folks can go and execute their daily tasks in the field of building automation. A bit about me. I used to manage the integration program at Johnson Controls. During that time, I've coded BACnet stacks and APIs in C#. I've done complex integrations. And if you see me at AHR next week, you will realize I'm bald. That is courtesy of being a technician and getting yelled at by contractors for the better part of, what is it, like 15 years now? Something like that. All right, so let's talk about our objectives for today. Our objectives are that we are going to discuss the programming process. That's going to take us about 10 minutes. We're going to write a real program. We're going to get as much of it as we can get done in about 30 minutes. I'm going to talk you through kind of what is this programming environment that I'm in, what is my thought process as I'm working with it, that kind of stuff. And then we'll do question and answer for however long you all want to ask questions. I'll just answer whatever I can. If I can answer it, I'll tell you. If I can't, I will get back with you with the answer. All right, so the programming process at a glance. Have you ever been on a job site? I remember my first job site. I've told this story so many times. For those of you who listen to the podcast, you're like, oh no, not the chiller story again. And I was asked to come and program a chiller, and I was about 3 weeks in, and I didn't know what I was doing. I didn't know what a chiller was. I didn't know what a central plant was, but I was out there writing programs, and it was at about this time that I had an older gentleman. I don't even know if he's still alive because he was like 60 then. This was a while back. He actually said, you know what? You totally just messed up this program. So here's what we're going to do. You're going to learn a programming process, and then you're going to he gave me a control stencil and had me write programs by hand on a piece of paper before I was allowed to go write programs anymore. And the process is that we focus on our inputs and outputs and set points first. Then we work on our start-stop logic. Then we add our control states. Then we implement any safeties and shutdowns, and then we work on auxiliary control. So as I work through the program today, and as we look at the sequence together, that's what we're going to be identifying. And so as you come out of this webinar and you leave to go back to writing a program, or maybe tomorrow you're writing a program, I want you to look at your sequence of operations and think about, how can I pull these different points of data out of that sequence, and how can I translate that to a program? All right, so a specification, I'm not going to spend a whole ton of time. I know a lot of the names on this webinar, and I know you all know what a specification is. So specification quite simply tells us what the system is supposed to do. Some of them are awesome and they give a lot of detail. Some of them look like someone, went out to a bachelor party and wrote down something on a napkin and just delivered it to you the next day. So sometimes they're good, sometimes they're not so good. The plans sometimes also have sequences. Now, the thing with this is, oftentimes, to my just amazement that this still happens, the plan sequence does not match the specification sequence. So that's something to be real careful about when you start programming, is make sure they match. And if they don't match, submit an RFI, request for information. Just make sure you get everything straightened out before you start writing code. And also, you have your own wisdom, right? That's a good source for programming. If something just doesn't make sense, or you realize you don't quite know what's going on, then just reach out to someone. So that's my basic primer right there. So let's start, right? So we got our inputs and outputs and set points, which I'll show you how to pull that out when we pull up the sequence of operations in just about 7 minutes. But once you've done that, we want to do our start-stop logic. So start-stop logic is any logic that is going to give us a true or false on-off state. Oftentimes I see folks just start writing, and because of this, their programs are all wonky because they don't determine their start-stop states. They start writing loops, and then they realize, oh, how am I going to enable this loop? And oh, now I need to go write some comparative logic for outdoor air enable. And oh, and then before you know it, the program's a mess. They don't know where they started. They don't know where they stopped, and things are just ugly. So like to start off by just turning things on, because honestly, quite often, whether we're doing a chiller, whether we're doing an air handler, we have some linchpin on-off state that determines whether that program's going to work. For an air handler, it may be opening an outside air damper. For a chiller, it may be enabling the isolation valves. We need to figure those out and get those written. From there, we move into our control states. So this is where we're going to be writing our analog logic. This is what throws a lot of people for a loop. Most folks, when they're writing programs, can get this start-stop logic right. You know, hey, throw in a comparator, compare outdoor air temp to outdoor air, lockout, enable the economizer. That's a basic start-stop on-off logic, right? It's when we start to get into the control states that some folks will get lost. And I will tell you, once you learn how to write control states using patterns, it's not that bad. PID loops, things like that. Once you learn to use help files, you start to understand the parameters behind a PID loop. They're not too bad. I know that seems easy for me to say when I've been programming as long as I have, but I'll tell you, using so many folks' different software, there's a couple scenarios you'll see time and time again, and once you get those, you'll be good. And we'll see that when we start programming. And then we got to implement our safeties and shutdowns. We always program these last. This is like, if I had a golden rule, this would be it for programming. I've seen too many times when folks implement a safety at the beginning of the program, and then after the fact, they start programming and they override that safety without even realizing it. So we always want to put in our safeties last. And then we have our auxiliary control. So our auxiliary control is going to be, hey, I've got a space and I've got a cabinet heater or something like that, and I want to enable it. Well, that would be auxiliary control. Okay. All right. So let's write a program. Any questions so far, though? Pretty straightforward. I don't believe in doing long PowerPoints. I don't think people learn very well from them. So I like to show you actual real world, and we're going to do just that. But while I bring this up, I will take any questions anyone has so far. Nothing. Okay, that's awesome. All right, so let's dive in. So here is a air handler. I grabbed this off of Equipment Builder. Which is an ALC software, and I just randomly marked stuff in Equipment Builder. I don't honestly even know what I marked as far as choices, so this will be interesting. But when I did that, it builds a sequence, and this sequence I know is a VAV air handler. And what we need to do whenever we're approaching a sequence, so we've got the sequence, we first need to figure out what points we have, right? Because we're going to do inputs and outputs, and then we're going to do our actual set points. Now, I'll be honest with you, most of the time when you do set points, you're going to miss some. That's just the reality. And it's okay to miss some. You're trying to get the big ones up front. So if we go down here, this is kind of nice in that it tells me all the points I need, right? So right off the bat, I can see my AIs, my AOs, my BIs, my BOs. Everyone comfortable with what AIs, AOs, BOs, BIs are? If you're not, just type it in chat. I can go through that real quick because I don't want to be saying AI repeatedly, and you all are thinking I'm talking about artificial intelligence, and you're like totally lost. So I'll wait a second. If I don't see anyone, I'll just continue on. And I won't call you out. Okay, so you don't know? Okay. All right. So analog inputs are a variable input. BIs are binary inputs. They're a two-state input, right? So two states, on, off, true, false, alarm, normal, etc., etc. Binary outputs are two-state as well, on, off, open, close, etc., etc. Analog outputs are variable states, so 0 to 100%, 0 to 50, 0 to 10, etc. So analog inputs and analog outputs. Analog inputs you're going to use for temperature, pressures, humidities, CO2s, etc. AOs you're going to use for speeds, dampers, valves, anything that is a variable position, not a two-state position. Whereas binary inputs are going to be a two-state position, true, false, in the case of on-offs, on running. And oftentimes a binary input is just a true, false. It's a 1-0 state, and you actually set the state text either in the graphics or you set it in the points themselves. And binary outputs, right, that's on, off, open, close, etc., etc. And you have analog values and binary values, and those are AVs, BVs. So, alrighty. So right here we see we've got return air temp, mixed air temp. But how do I pull this out if I didn't have a point sheet? Well, what I would do is I would just start working my way down, right? So run conditions, there's an adjustable schedule, and I would just highlight that. So this is why I like to do it in Word or in PDF. And say, oh, the unit generates an alarm based on freeze stat status. And I would make this a different color, like green. So yellow would be my logical points, set points, and green would be my physical points. This could be any color you want, but it just helps to go and use different colors. That way you start to pick them out. And so high static safety. What's a high static safety? It's actual physical point. So we'd use green again. We have a supply air smoke detector status. That's another physical point. You all are seeing this. I don't literally have to go through every point. We don't have enough time for me to go through every point. But I will go through one more section just so you can see, right? Supply fan will run anytime the unit is commanded to run, unless safeties. We've got a minimum runtime, which anytime you see adjustable, that's a sign that you are dealing with a set point, okay? And so we have supply fan failure, commanded on, and status off. It doesn't really say on and off right here, like supply fan command, supply fan status, but I can infer that both of these are points, right? Status is on, status is off. And I can start to see this. I also see I've got a runtime alarm. So that's how I start to build out my list if I'm not as lucky to have the list I have down here. So once I go through that, then I go through and I start to look at my on-off status or my on-off command states. We have one right here. So I'll pick a color. In our case, we're just going to say blue. Blue does not go well with white, so we're not going to do blue. We'll do red. Red goes semi-okay. So red will be my on-off states, and then if I have an analog state like this pressure control, I would mark it another color, which we'll just say is purple, okay? Now I have a lexicon, essentially, where I can say, okay, I could real quickly scan through this sequence, and I can say, all right, there's a Boolean state I need to program. Here's some physical points I have. Here's a variable that I need to program. And I can start to add these to my program. So this right here is known as a programming environment. This is GFX software by Distech. I've always been a fan of Distech. Ever since I used their lawn controllers back when I worked with Johnson Controls, I always just liked their programming environment. It was very neat and clean and just easy to work in. On a lot of environments, what you will tend to have is you will have a toolbox, a palette, an input selection, whatever they call it, that allows you to draw from a series of blocks. Because I'm only going to teach you block logic programming because the majority of the market uses block logic programming. So if I'm thinking of a personal investment and just, hey, what would be most valuable for me to learn? It would be to learn block programming. It's going to have applications across the most control systems. So under a programming environment, you will have your blocks. You will also have different properties of your block. So if I were to add a hardware device right here, and we kind of scroll up to it, if I were to add this device, I would be able to configure it right here in the configuration. We'll talk more about that in just a second. Any questions so far, though? Pretty straightforward? Okay, good. I'm going to drag this to my other screen. You all will not be able to see it. I will attach this. Hold on. Give me a second. Let me I'm going to save this. Yes, we're going to save this. Hold on here. There we go. What I'm doing right now, folks, is I'm going to attach this program or this sequence. That way you can use it. You can kind of follow along as we work on it. So give me just 1 second real quick. And I'll grab it for you. There we go. Copy. And choose a file. Paste. Okay. There we go. Okay, there you go. Oh, it's not going to let me do it because it's not in Word format. All right, I'll email it to you all after the fact. Anywho, doesn't matter. So we will go and I will start building out this program. And I'm going to build out the points first. So whenever you're building out points, it's really important to understand the kind of controller you're going to be programming to. You need to understand the capacity as far as the inputs and outputs that that controller has. There's nothing worse than writing a program only to realize that you're going to have to split the program across multiple controllers. And this is something I see a lot of folks make a mistake on when they're new to programming, is they're like, oh, I could do that. And they start to write all this logic only to realize that they have no controller in their product line that is capable of actually going and executing the program. Now, the good news is most of the controllers these days have expandable I/O. But if you did not plan for that in the project costs, that can be a problem. All right, so let's go in and let's start adding points. The first thing we're going to do is we're going to add our physical points. So we see right here, we have a mixed air temp, and I'm going to add that. So I'm going to go in here, I'm going to add MA-T, and since it's a mixed air temp, we're going to say that it's an RTD. And we're going to pick which type of thermistor it is. In most programming environments, you are going to have to configure all of this information, right? You're going to have to configure the signal type. You're going to have to configure this, the type of sensor. And sometimes, though, it'll do it automatically for you, but most of the time it will not. You can also set all sorts of variables in here, right? We could set out of range. We could set an alarm if we wanted to. This programming software allows us to do that. Other software, you may have to do it in the form of an extension. So we're just going to click OK. I'm going to very quickly add some points here. We're going to start off, actually, I'm going to grab SF-S for supply fan status. I'm going to go and grab a hardware output for SF-O, supply fan output. And I'm going to grab another one, and I'm going to call it FS-C for supply fan command. Now, O, standing for output, is assigned to me that this is going to be a variable. So an analog output. So I'm going to set this to 0 to 10 volts. Right here, I've got my configuration set up. We're all good to go. Percentage, that's the object unit I want. And then for this, I'm going to set this to a digital output. It's going to be on off. And you can see I can actually go and configure the state. Remember how I told you we can configure states? Let's say instead of true false, I want it to be on off. I click OK. Now we have on off. Now let's go back to the program real quick. And actually, while I'm here, now I am going to deviate from my process just due to time. So if you're like, hey, he's not adding every single point. He's adding some analog points, some variables, and he's adding physical points. That is purely because of the amount of time we have here. Otherwise, I would take the time and I would add all of my points first. But here I'm just going to grab a generic, right? I'm just going to grab a basic point, generic BV, and I'm going to call this OCC. That's going to be my awk command. And I'm going to scroll up to my sequence here again, and it's going to say the unit will run based on operator schedule, right? So that's where that awk command came from. Remember, we're not doing safety circuit first. We're going to do the supply fan status first. So supply fan is going to run anytime the unit is commanded to run unless shut down on safeties. To prevent short cycling, it's going to have a minimum runtime. All right, so what does that tell us? That tells us that we need a time block in here, right? So we're going to go here, we're going to grab time, and we're going to grab a block called minimum on time. Okay, so we're going to go and output to our input. And we're going to go here and configure our minimum on time. See, on some blocks, you can just click on some software, you can click and actually go and set up the values inside. Like if you're familiar with Workbench and Niagara, you would actually click on the block and you would configure it in its property sheet. In our case, though, we're going to grab a constant. And this is another point, internal constants versus internal variables. So if I want a variable that can be changed, then like a set point, I would go and use an internal variable. If I want it to stay inside the program, I would use a constant. Now let's look at that sequence one more time. Adjustable minimum runtime. So what does that tell us? Whenever we see that, that means to us that we have to do a variable. Because if we did a constant, it wouldn't be adjustable. I mean, you could technically argue that it's adjustable if you log into the program, but in our case, we're not going to try to argue that. We're just going to go here and we can set this to have whatever value we want to give it. We can set its persist. And so, if I want to set it to whatever, I would do that through the software. If we wanted to kind of preload it with a value, we could do that as well by going, and let's say it's got a minimum 300-second runtime. So we go in and set that up right there. And then we have our output come here to our supply fan command, which I'm going to just swap these real quick, okay? So here we've written some basic Boolean logic, right? We've got an awk command coming into a timer, and we've got our supply fan command. Now down the road, if we wanted to, we could go and break this with our safeties, right? We could break it with our high static safety, our supply air safety, our freeze protection safety, et cetera, et cetera. But we're not going to do that just yet. I'm going to pause. Any questions? I know I talk pretty fast. And I just want to make sure everyone's following what we've done so far. Everyone good? Any questions? Now's your chance. Okay. All right, cool. So now we're going to look at an analog sequence. So we've done a binary sequence. I want to show you an analog sequence. All right, right here we have the controller will measure duct static pressure. Okay, so duct static pressure tells us that is a physical point, right? And we'll modulate the VFD fan speed, right? Physical point to a set point. So we're going to grab our set point. And the supply fan speed will not drop below 30% adjustable. Another set point. That's going to be a limit block, okay? So when we start to write this right here, as we start to go through this, we're going to use what's called a design pattern. Now, if you want to get really fast at programming, you want to start designing design patterns. One of the things you can do that will really help you to speed up your programming, will help you and your business, is to build up a library of patterns. What do I mean by that? Okay, so supply air duct static pressure follows the basic pattern of input, process variable or input, depending on what you call it, set point, loop, output. So let's go and grab those points real quick. So the first thing I need to do is grab a hardware input. We're going to go and call this DAP, discharge air pressure. We're going to grab a set point. Okay, so let's just say we'll actually use an AV this time. We're not going to use an internal variable. We're going to use an AV. The big difference between an AV and an internal variable in this software, that is a BACnet object right here, the AV. That is not a BACnet object. So that has ramifications as far as discoverability goes. I just wanted to show you what this would look like. So we would go here, DAP-SP, set point. Okay. We would go to our loop block, which should be under, if I remember correctly, general PID loop. And so our pattern so far, process variable, set point, loop, output. And we also have an enable. Now, what I like to do is I like to say, hey, if I've got fan command, that's my enable. So you could do that off of the output. You could also do that off of fan status. The reason I prefer to do it off of the output versus fan status is in case you have someone who put the fan in hand and they're trying to run it and it shouldn't be running, then you're pulling off of status. And I'll talk about that in just a second, Lee. So you're pulling off of status, which could not potentially indicate that the output is actually on in the program. Does that make sense? That's why I almost never use status as an enable. I always try to use the output of the device as the enable. Now, input, pretty straightforward, right? We just grab our pressure sensor here and just, let me configure this real quick since this is pressure. We would go here. Typically, we'll do linear, and we will set it up based on voltage. And then we would configure our range, like 0 to 10 volt means, 0 to 5 inches. And that would be it. And we could actually set, our range if we wanted to here. Where's inches water column? I'm not going to spend your time or my time to find inches water column in here. Well, as I say, I'm not going to do that. I start searching for it. I'm not seeing it. Whatever. Anyways, doesn't matter. So I'll set that up and then I will have set point come in here. Now feedback. This is not on all loops, but essentially what feedback is that you would take the feedback of the output and bring it to feedback. The reason you would do that, right? The reason you would go and bring that in is because you want to see if someone overrides this output. So that basically tells the PID loop. This is something that's kind of specific to certain programming software, but it tells the output or the PID loop, hey, this output is overridden and here's what it is. So it doesn't keep trying to program it. But what we just did, excuse me, is we just wrote a loop. And now, depending on your software, depending on whose you're using, there may be different ways of going and setting up this loop. So what we would go and we'd do is look up help on this object. And we would read about how do we set up a proportional band? How does the integral time work? So that way we understand how we tune this PID loop. But once you know that, once you understand the basics of throttle range, P band, proportional, integral, how all that works, then you just need to know how it's calculated and you can go and actually set this stuff up. And then we would be able to open this guy up, set our proportional band, set our integral time, all of this stuff we'd be able to set and tune it. Now, this is a discharge air pressure loop. So as pressure drops, we want to go and increase speed. So as we drop below and as we go over pressure, we want to go and lower the actual output. So it's very much like a cooling loop. So it's direct acting. So we would not want to select reverse acting. Reverse acting would be heating, or actually, I just misspoke. We would want to select reverse acting because it's like a heating loop. A lot of stuff going through my mind that I'm trying to pass on to you all at the same thing. So we've got all of this to this point right here. Now remember, we still have the 30%, right? So we still have to do that. So what we would do is quite simply just delete this, go and find, I believe it is under our math. It may, So we would take a minimum. No. Yeah, I'm pretty sure it's minimum. Let me just double check this. Use to output the lowest minimum value. No. Maximum. Maximum's what we want. That's right. I always get these mixed up in Tritium and everyone else's software. So this one is going to take our max, right? So it is going to output the highest of the inputs. So in our case, we're then going to take an internal constant, right? We're going to set it to 30 here. So double click here, 30. No, don't double click. There we go. No need to double click. That's the only downside of programming in multiple different softwares. You start to like intermix your habits. And so then we go here and that is our max select. And now we have our 30%. So that then is a limited loop. And we will use this exact same pattern when we're going and doing economizer control. So when we're going and having CO2 reset, where we could reset the damper down, we can use a minimum select object instead of a maximum select. But essentially, we just wrote our supply fan control. Now, granted, we don't have our safeties in here, but we can continue on because we're going to come back to our safeties later. So we're at 12:30 right now, so we got about 10 more minutes of programming. Any questions? So Mike asks, why is it max and not min? Remember, help on this object. Let's read this. Use to output the highest value of the inputs. So is 30 higher than 0? The answer is yes. So if I use a maximum, I am always going to be outputting 30. Now, here's the thing. If I use a minimum block, let's grab that real quick. Minimum. And let's look at the help on the object. If I use a minimum block, it outputs the lowest input. What if my drive is 0? Then it's going to output 0, not 30. So that's why we use the max block. Some folks will call it a high select. Some folks will call it a min-max average. It just depends. So the block functionality is going to remain the same. The name just may change based on software. So we've got our maximum block in here. We're good to go. All right. So now we're going to move to preheat. So preheat, we know just right off the bat, preheat is a Boolean stage. And we said what color's Boolean or Boolean state? So we're going to go red. Controller will measure mixed air temperature. So we just found another point. And we'll stage the preheating to maintain its set point. So we've got stage preheating and we've got a set point, which is going to be a variable. Let's go here. I don't know why I just turned it red, but let's undo that real quick. There we go. And the supply air is less than the supply air temperature set point. So that's another variable. And to prevent short cycling, we will have a min runtime, which is going to be our min block, right? Preheating is going to be enabled whenever outdoor air is less than 60 degrees. So we know we have a physical point, OAT, and we have a OAT set point. The economizer is disabled. That is a logical point. And supply fan status is on. That is a physical point. Preheat stage will run for freeze protection whenever mixed air temp. We already have that one flagged, so we don't need to flag it again. Drops from 40 to 35. I really don't like this. It should just say when it drops below 40 degrees. Because what happens if it goes below 35? According to this sequence, I don't do anything. So we're just going to highlight 40. I would make a little note to myself to RFI this. But we're just going to say, 40 degrees. And the supply fan status is on. We still know that. Okay, so let's start to work through this. So first thing we need to have here, we have a mixed air temp. We'll just drag this guy down right here. we need to have a preheating stage. How many stages of preheat does this thing say it has? Let me see if it says. BO. Preheat stage 1, there's only one stage. Okay, cool. That makes my life easy. I chose well. All right, so we go over here, grab this, call this ph-o, or command, actually. Then we just configure this, say it's digital, and we could just set our default value on off. And sometimes you won't even do this. What you will do is that you will go and you'll actually let field configure this. You'll let field configure inputs and states, and you will just write the program. So sometimes doing that, I personally like to go and configure the points for them. I mean, it only takes a couple seconds. So, and then Chad says, I think the sequence means there's outdoor temp is less than 35, disable when it's greater than 40. I mean, that may be true that there is a state between there. It's a confusing way to write it. I would use a table and I would make it very clear. I would just have a table there that would say enable, disable. So mixed air temp. All right, where were we? Gotta remember. Can you tell I'm ADD just a little bit? All right, electric. So mixed air temp, stage preheat. We have a preheat set point. So we're gonna go up here to our generic analog value. We'll just use this one in here. I mean, we could still, like I said, we could still use an internal variable. We could do that as well. So, whatever you want to do, it's up to you. They have different purposes. I'm not going to get into that though in this. Just realize they do have different purposes. There's different scenarios. Okay, so mixed air temp set point. We also have a supply air temp set point. We'll just copy that and drag it down a little bit. And we'll SAT-SP. I really do not like them calling it supply air temp and calling it instead of discharge air temp. But once again, just personal preference. So preheating will be enabled whenever OAT. So that means we need a physical point here. OAT is greater than 60 degrees. So we actually have an OAT enable set point. So we'll label this like heating OAT enable SP. And you could actually put a description, this is, heating outdoor air enable set point preheat, or actually we call it preheating. Go to the back. So it's really up to you. I normally like to put descriptions if I'm able to. And so we've got that. We've got our minimum runtime, which we're not going to do yet. We have economizer is present, which we'll talk about in just a second because we haven't written any economizer code yet. And we have the supply fan status, which we know is up here. And I'm just going to drag it down for here to make it simpler. And then we have this convoluted mixed air temp drops below. So we're just going to call this freeze protection set point. So we'll just copy this. And I don't want to copy that one. I'll copy this one. Just because this one's not got a description on it. We're going to call this mixed air temp low limit SP. All right. So I've got mixed air temp and all right, the controller will measure mixed air temp and stage the preheating to maintain its set point 5 degrees adjustable. Now here's where things get a little weird, right? So we have this startup and we actually we have this PID loop. And there's a couple different ways we can do this, right? We can do a digital stage, right? So a digital stage is going to, let me show you. Here we go. It's going to take a PID loop and then stage it on, okay? So it's going to say, hey, I'm going to stage this on. And if we had, actually, I'm going to change this sequence real quick. I'm going to say we're going to have 2 stages preheat. I mean, come on, just since it'll make it easier for us, or not really easier for us, but it'll just make it more interesting because now we can actually use this. So with this right here, we're doing a enable, but we're also doing an analog state at the same time because I'm using a stage device. Some folks would call this sequencers. It would be called a sequence block in some programs. And the important thing with a sequence block is, right, we have our output that's going to turn our heating on. And then we have to go and have some way for this stage to know that it turns the heating on. So to do that, we're going to come back to our loop. So I just got to find where loop went again. It disappeared on me. There we go. I would grab this. This would be my output. It would come here. And we would say, what? Mixed air temp is driving to set point to maintain its set point 5 degrees less than the supply air temperature set point. So first off, we grab mixed air temp, and that is going to be our input. And our set point is going to be mixed air temp minus is 5 degrees less. So it'd be supply air. Man, this is a convoluted ass way of writing this. Maintain its set point 5 degrees less. Okay, cool. I see what they're trying to do. So we're going to go here and we're going to grab a math block and we are going to subtract. And with subtraction blocks, it's really important that you pay attention to the order. With subtraction and division blocks, you need to pay attention to the order because if I put, supply air temp minus 5, that will give me a completely different result than 5 minus supply air temp. So always pay attention. And the same with division. I see that's something a lot of folks tend to mess up in the beginning. So this would actually go and I would interrupt this with my set point, which would now come here. And then this would go here and I would grab a constant, or no, I would not grab a constant. I would grab a variable, but just for giggles, we'll just put this right here. I'm going to move some of the stuff over because it's taking up too much space. And this would be my set point. I could label this if I wanted to. That way I would be able to go and see this in the graphic, this set point, and it not just say internal variable. So if you want to expose something on graphics, make sure you label it. All right, so we've got all this. This is all programmed to run. The problem is it's not programmed to be enabled yet. Because remember, we have our enable state. And we also don't have our minimum runtimes in yet. So we would want to explore this right here and see, hey, does this give us a minimum runtime? Which it doesn't, right? It doesn't give us a minimum runtime. I wonder, I don't know off the top of my head. We have digital. Yes, this does give us a minimum on time. So we would go, and this is why it's important to know your blocks. We would just delete this, output here to in, output, output. And now we've got our minimum on off. Okay, so minimum on off is going to be minimum runtime. And we would go and create an internal variable. That would be our minimum runtime, minimum on, because it does not say minimum off. You all with me so far? You still following this? Everything making sense? Any questions? Because we're about, I think after this, we're going to pause and just take question and answer because we're running up a little bit past where I wanted to start question and answer. So I always choose these programs that take longer to write than the time we have allotted. All right, so outdoor air temp is less than 60 degrees adjustable. We're going to have that. And then we have our economizer present and our supply fan status is on, and that enables preheat. Okay. And then, oh, by the way, we also have preheat stage will run for freeze protection. The only thing I don't like about freeze protection is it doesn't give us a separate set point for freeze protection. So we just have to assume that we're matching this, which I don't particularly like, but that is what it is. So outdoor air temp is less than, right? We'll go here. We'll grab outdoor air temp is less than 60 degrees. And this is where you have to make a decision. Do I do less than or equal to or less than? The logic says less than, so we're going to go with less than. So outdoor air temp is less than our set point. We also have economizer is present. You're going to have to pretend that we have an economizer is present because we're not going to have time to write that. So what we would do is then we would go to our logic block. We would grab an AND block. And what I like to do with my AND blocks, this is a little tip. I like to follow the sequence logic. So outdoor air temp is less than 60. I like to do, okay, outdoor air temp is less than 60 and then boom, and the economizer is present. So economizer would be there. And then, supply fan status would be the next one. Since we don't have the economizer logic written yet, we would just leave that blank. And what I would do is I would open this up. I would enable the third point and I would map in the next thing, which is supply fan status, right? So I would go here. So we have this. So that and then we have an or, because now we're writing our low temp logic. So we have or, and we're going to say or these variables, right? And the supply fan status is on. So we know the second one is going to be right there. So we'll grab our and, grab our supply fan status for that. And then mixed air temp drops below 40 to 35. They may have a hysteresis in here. I believe they do, but I forget exactly what it's called. I'm not going to spend a ton. Oh, there it is. So hysteresis is basically a state. So it'll change on and off based off of states. So I would take my right here, my 40 would go into switch on, or rather my. See, I don't like this. I really don't like how they wrote this. I'm not even going to do that because it's just going to confuse people on the call. So I'm just going to do something simpler. I'm just going to say less than 40 degrees. And that's going to go into here. And then I would take my internal variable and it would go right there. And then these come together, this OR block, and it enables the PID loop. And it also enables my stages. And that's how I would write this. So there you go. That is how I would approach writing that little snippet right there. With that being said, we're about 12 minutes left in the webinar. I want to give you all time to ask any questions you have. So feel free to just ask away anything you want to know. And I will start working through your questions. First off, thank you so much for taking time through your day. I hope this was valuable for you. So let's see. All right. Cooling only, heating only. Yeah, definitely, Chad. I should do a very simple like rooftop unit for the program. But I just wanted to pick something random that would be something I haven't seen. Well, I've seen it, but I mean, I didn't look at the sequence beforehand so that you all could kind of see how I think through this. I wanted you all to experience that. So Jeff, reach out to me offline and I will talk to you about that. When you finish your logic, how do you transfer to the controller? Great question. That's a brilliant question, Orlando, because that brings up something I didn't cover here, which is the difference between live programming and compiled programming. So GFX is a compiled programming software. I build it and then I send it to the controller. Whereas Workbench is a non-compiled program. I literally build it in Wiresheet, so is EasyIO, and I make changes on live programming. That can actually be quite dangerous because you can go and make changes on live programming and literally break stuff. So I personally am a fan. I prefer build and send because I compile it, I test it, and then I send this to the program after I've tested it. And I can simulate this. I could run this in a simulated mode. So yeah, great question. Let me grab this and move this out of the way so I can see y'all's questions easier. Okay, here we go. Perfect. There we go. Okay, next question. So Ryan says, can I explain the feedback from the fan control back into the PID loop? Bit confused why we would need this. Okay, you've got Boiler Bob. And Boiler Bob decides that he is now Air Handler Adam. He has changed his name. And he decides that he's going to go up to the VFD on the controls, and he is going to override this output to 100%. Now, naturally, the VFD was calling for 40%, and it's like, hey, what the heck? I'm like way overshooting my discharge air pressure set point. So the loop starts winding down and winding down and winding down. And next thing you know, the loop is like negative in its calculation. Problem is, you show up on a job site, you're like, what are you doing? You don't override that. And you release it, and then the loop's all going erratic, and it looks like you're having an earthquake if you look at the trend log. The way to avoid that is to take the feedback of the output, feed it into the PID loop, and the PID loop will know that the output is overridden, and it'll say, hey, this is overridden. I'm not going to keep winding up. I'm going to understand that someone has done something they should not have done. So that's why. Thank you for saying it's valuable. That's awesome. Great webinar. I am using GFX by Distech. This is part of their Eclipse product line. They're one of the manufacturers that produces controls. So yeah. The V on blocks. Can you also summarize the meaning of the different colors of blocks and what they mean? Like the colors in Distech? That's a good question. I'm sure I could. I don't know off the top of my head why they have the colors they have. I used to know for when I was using their software to program lawn. It's basically the type of point. It just gives you the ability to look at a program real quickly and see kind of what blocks you're using. I believe it's the category, if I remember correctly. So like the general blocks have a specific category. The constants and variables have a specific category. Comparators have a specific category. So you can kind of read through them real quickly. Can I please email you the hardware software point matrix and the written specification? Yeah, definitely. Is there a free trial copy of this program? You'd have to email Distech about that. I believe they have a copy of GFX, but I'm not 100% sure. So Chad says, I like it. Taking a sequence to control logic is tough to do. It is definitely tough to do. What we did not have time to discuss, and I teach this in our programming course, is moving around the blocks. Like you can see, this electric preheat is dependent on economizer. So I would go and I would probably move the economizer block in front of this as I rewrote the sequence. That way I could program it. That is kind of how I would do that. It's how I like to think through it. John says, how hard is it to get this information from an existing system for review and comparison? Are you talking about like how hard is it to upload a program? It depends on the software. As long as you know what you're doing and you have access to the software, you can pretty much upload programs from any controller out there. As an industry, we really don't have very good security practices on protecting against people just connecting to a controller and pulling programs out of it. So as long as you have the software and tools, you can pretty much do it. Excuse me. Sorry about that. Didn't mean to cough in y'all's ears. I was late getting to the webinar, so I missed it. Is it recorded? Yes, and it'll be put on YouTube as well as our site once I'm done recording it. What's the software I recommend for beginners? Anything. I mean, EasyIO CPT, Distech GFX. I think both of those are free software if I remember correctly. And so I would recommend that. And they both have simulation, although EasyIO CPT is live programming and GFX is compiled. So how do I implement controller watchdog logic? So when the controller goes offline from a supervisory controller, it goes into a safe operational state. So you would have a heartbeat. It would be a network variable. And you would then have switches that would switch that based on the heartbeat. So I would create a network variable, and if I lost status, if that network variable went false, then it would switch states. So there's that. Some programs actually have heartbeat code, if I remember correctly. So let me see. I would have to dig into the help to remind me. I could have sworn that there's a heartbeat in this. I think it's, I have to remember. I don't remember off the top of my head. So, Bitakin's worm. UFM, most manufacturers are moving to block-based over line. Okay, so as Ryan asks, are most manufacturers moving to block versus line? I know that Siemens, with their newer solution, are moving towards block. I know KMC has a hybrid. I know Delta and Reliable still use line code. I tend to find the majority of folks are using graphical just because it's easier to learn. You don't have to worry about learning coding and functions and all that jazz. And depending on who you talk to, in my opinion, it's faster. You will have folks who have used line code their entire life, and they will argue line code's way faster and they could do more with less code. And I'm like, yeah, but no one can come and understand what the heck it's doing unless they know how to read line code. Whereas, someone who works on a completely different system could probably figure this out, even though they don't work on this software. I think that's one of the benefits of block-based programming. Kevin says, can an individual set up a practice station with controllers? Yeah, there's no reason why you couldn't. Yeah. Spencer says Distech GFX is free via the Smart Install software. Yes, that is true. Chris says, thank you. What's my method for debugging my programs? How do you ensure that they will work? So a couple different ways. Excuse me. Let me take a sip of. Drinking coffee when your throat's dry is probably not a good idea, but anyways, it's all I've got. So there's a couple different ways, right? You can start with the end result and work backwards. You can do a logic read, which is you read the sequence and then you read the logic out loud. So, discharge air pressure goes into the PID loop and discharge air pressure set point goes into the PID loop. And then these output and they go into a maximum block and it selects the higher of the output or of the 30 value of 30, and then it outputs that to the supply fan output. And I read that out loud and then I validate that against my sequence. So that's another method for doing it. You look kind of crazy when you're sitting in your cube reading code out loud, but I mean, it works. The specs of logic to be implemented, from where is that coming? From designers, consultant? Most of the time that comes from the consulting engineer. They will send you a design spec, and then you will interpret that spec and respond to it in your control submittals. All right. Spencer says, in the newer programming software, how often do these programs run? So typically every half a second is the average runtime for a controls program. You're welcome, John says it's very good. Jeff says he's N4 certified, and the program I used here seems easier to navigate than Workbench. Yes and no. Workbench can be a very unforgiving solution if you're unfamiliar with it. But at the same time, for me to go and template a program, which I could do in Workbench pretty easily, I have to grab all this. And then I have to go and save it as a code snippet. I have to manage my code snippets, all that jazz. If I want to have multiple programs open, I have to have multiple program sheets, and then I have to link. And I tend to find that with Workbench for enterprise-wide programming, globally, it's easier. For individual controller programming, yeah, I mean, that's all this tool is primarily focused on. It's not the only thing it's focused on, but it's its primary focus. Although Workbench and Wiresheet is pushing out to the edge with like the Edge 10 and things like that. So Steve says, good wondering, could I still see the Niagara one? Yes, it should be on our site. Go on our site, it should be there. So Chad says, hope everyone implements. Yes, I do as well. Thank you. Off the wall question, EasyIO was just bought by JCI. What do I think? I don't think that does anything to the market. I believe EasyIO is still a solution that is going to be brought to the light commercial and medium commercial sector. I think for them, it fills a hole in their line card that Metasys was just too expensive for the light commercial sector. I also think it opens it up. Well, it'll be interesting to see if the branches start carrying EasyIO or not. That'll be interesting. That'll indicate a lot as to their strategy. I think it's going to formalize their product development cycles. I think it's going to make their support documentation a lot better, which was a weakness of EasyIO's. And I think it's going to give them better buying power as far as material components. So in theory, costs should stay the same, if not go down for the cost of the product. Brandon says, how much would a person have to know about a specific unit in order to program it? So it normally depends. I always recommend folks go through the equivalent of our HVAC control sequences course before programming. I tend to find understanding how systems are sequenced will make it a lot easier to program. But that's not to say that you couldn't just go. I mean, literally, I taught myself with the Honeywell Gray manual and a control stencil. I screwed up a lot of stuff along the way. But I mean, if you have time and you're willing to put in the hours after work, you can teach yourself this. I think that having a formal process around learning sequencing and then having a formal process around programming, especially design patterns, will make it much easier. Lee said, thanks, great webinar. It's awesome to have seen you here, Lee. Can block programming be converted into code? So it depends on the software. So block programming can kind of sort of be converted into code in Workbench. You can actually move between Java and not Java. If you go through the developers training and that Niagara puts on, they'll teach you that. I don't know why you would. KMC does that natively. They support switching between graphical and line code. But I don't know why you would, because that really precludes you from being able to work with the market. All right. So, how do you manage working with different products and devices, specifically the way they are programmed? I find it hard to stay on top of each one. The first thing I do, okay, so we're recording a course for Automated Logic right now for their dealers on Icon. And so their dealers have asked us to record an Icon programming course. And I mean, I've worked with Icon. What I find interesting about it is it's different, but it's the same. And so even though some of the blocks and things are different, I understand, one, how to read a help file, which is, I mean, if you get one skill down, learning how to read manufacturer documentation and search it for exactly what you need, that thing will pay dividends. But then beyond that, I know what an AND block is. I know what a PID loop is. I know what I'm trying to do. So it's just a matter of finding the piece of Lego that matches what I'm trying to do. So most of my time, whenever I'm working with another manufacturer's software, is purely just as I work through the program saying, okay, I need a min on block. In Niagara, it may just be called a timer block. In Distech, it's called a min on off or min timer, min on timer, whatever. In EasyIO, it may be called something different. And so it's just a matter of learning the names. So there you have it. Alrighty, any other questions? Anything else any of you all want to ask? I mean, I'm here for you. So I will answer anything you want to ask. I mean, this is your time. I do want to say, as we wrap up this, that I do appreciate you all's time. I hope this was immensely valuable to you. I never want our webinars to be something where you're like, oh my gosh, I just wasted an hour of my life that I will never get back. So I hope that this was helpful. Alrighty, good. I'm glad to see you all found it helpful. What else can I cover though? What else can I answer? What other questions? Yeah, that's great. Looking forward to seeing you there. Thanks, Jeff. Yeah, definitely reach out and email us and we will get in touch. For those of you who don't know, because I've had a couple of you mention, especially for those of you who manage teams and lead teams, we provide an online skill assessment that will tell you or tell you what you personally know or what your team knows. That way you can create a learning plan. So if you're trying to figure out what you yourself know or what your team knows, that's a service we provide. And you're welcome, Jonathan. I'm so glad. I just gives me like goosebumps every time I hear folks say that stuff was valuable to them. I just wish this would be around. Yeah, if you can reach out to me with your boss's email, then I can send you some more information. How to create a HMI starting from control logic. Maybe this will be a topic. So basically, yeah, we did something in our Niagara Basics course that is very similar to that. I don't see why we couldn't do that, why I couldn't map in some controllers. It'd probably be easiest to do it on Workbench and plug in our Edge 10 controller we have and map that in. I don't see why that couldn't be done for a future webinar. That's a good idea. Let me see. Drew's asking, any drastic changes you see in the use of cloud services and how that affects? Yes. So I had a really interesting interview with 75F, their CEO, about a couple weeks ago. I think it went live last week. And they actually are taking the approach, and this is what always boggled my mind. So manufacturers create their solutions, they put them in the cloud, and then the customer says, we're not going to actually use this solution because it's in the cloud. Well, 75F kind of headed that off by saying, hey, you can have our code and just put it in your own private cloud. So I think a lot more manufacturers are going to move to that perspective. I think also we're starting to see IT step in to a lot more projects. I was at a large consulting engineer who's a customer of ours, and they were talking about just their interaction with IT and how IT affects them on projects. IT is completely comfortable with SaaS and cloud. And so I think you will see greater adoption of SaaS and cloud. I think one of the areas that the industry is missing right now that is huge miss is the use of SaaS technologies and like cloud-based consolidation of customers' different building systems into like a centralized monitoring dashboard. I mean, imagine this. You're a company and you've got your customers different BASs. Like they got 4 BASs, 4 different manufacturers. You pull them into a central dashboard and you're watching them and you're paying someone 15, 20 bucks an hour, right? To watch this dashboard and just report on alarms. And you've got a team of people doing that. And you've got one higher level person who is over that team and who's analyzing the results. And then you're dispatching service calls. I mean, that is like a pure cash flow opportunity that I'm still just bewildered why companies aren't embracing that, because I know there's owners who are asking for it because they just simply don't have the staff to operate their buildings. So I think that is a huge miss by companies who are not building up that sort of talent and expertise within their organizations right now. Alrighty. Anything else, folks? Anything else you want to know? If you all are going to be at AHR, just FYI, we're putting on a BAM get together Sunday. It's going to be at the Yard House in Orlando, and it's going to be from 12 p.m. to 3 p.m. Eastern time. It was going to be 2 to 5, but I've been asked to go to the Control Trend Awards, which is awesome. And so I'm going to be going to that. So yeah. Can I quickly review the input column boxes represent again? Input column boxes. Input. Oh. Yeah. You're talking about this right down here. Right? This right here? Right here, Mark, right? Or here. What? Sorry, I'm trying to figure out yes to which one? To the GFX program or to the Word document? Okay. And the input boxes. The input column boxes. Oh, okay, like on here, right? Right? Like where my mouse is spinning. Hopefully you can see my mouse spinning. I'll draw a circle. Do I have drawing tools? Let's see. Do I? Oh my gosh, I've got drawing tools. It's amazing. Right here? That is, why is it brown? Like the worst color for a drawing tool. Right here? Yes. Okay, cool. Okay. So, okay. All right, I see what you're saying. Now, how do I erase the drawing tool? Erase all drawings. Now, do I get back the pointer? Okay, perfect. Okay, so these are inputs. These are physical inputs. Discharge air pressure is a physical input. Supply fan status is a physical input. That's just my way of shortening the name. I mean, you could call this anything you want, right? DA underscore P, DAP, DA dash P. I like to do the first letter of each word and then dash and whatever the measurement is. So for example, supply fan dash status, discharge air dash pressure. That's just how my brain thinks. Well, so question was asked, how much time from learning this to actually getting a job? That depends on you. It depends on one, your capabilities of grasping the information. Like if this really clicked with you, then that's a sign that, hey, then I'm kind of making sense of this. I'm a little bit ahead. If this was like you were completely confused, none of this made any sense, and you're still like, did I attend a webinar? I did something for an hour, but I'm not quite sure what I did. Then that kind of tells you where you're at from like your knowledge perspective. That being said, there's people who within a couple months of focused effort will have a job. Something it's just a matter of figuring out what you know, applying a training plan to close your gaps, and then going and applying. I will tell you, I've talked to hiring manager after hiring manager who has said, if you are invested in self-development and you're working to develop yourself, they're looking for you to work for them because it's so hard for them to find people in this market who want to develop themselves. So I will not be in Orlando in March. I will be in San Diego in April, speaking at Niagara Summit, and I will be in Orlando next. I want to say next month, but it's actually next week for AHR. All right, how many programs will typically exist in a BAS? Do you create programs for each controller and for each utility system? So typically, programs will exist based on their uniqueness. So let's say you have a cooling only VAV box, you have a VAV box with reheat, a VAV box series fan powered. You may create 3 programs, and then you'll download that program to each VAV controller based on its type. You typically create a program based on its type, and then you modify the settings in the software. All right. I've always seen controls contractors surf through this while we functional test, but have never seen how it's actually made. This was great to learn from. You're welcome. Yeah, I really hope this helped out because I think it's a good skill to have. And I want to do something different. Yeah, man. I mean, there's stories upon stories of people who have changed their careers. And I mean, this is a field that if you focus yourself on, you could be 6 figures within a couple of years. Easy. It's just a matter of picking your niche. Do you want to be a programmer, designer, integrator, whatever you want to do, and then focusing on that with relentless focus. Are controller manufacturers offering, are you asking, are controller manufacturers offering a kit? That's something I've actually been working on, and I need to get that flushed out with some distributors, because that's something we've been asked quite a bit. And you're welcome, Drew. You're welcome. Feel free to ask anything else you all have. Otherwise, once again, thank you so much for your time. You all are awesome. I mean, it's an awesome opportunity to be able to serve every one of you, be able to share something I'm particularly passionate about. So